Okay, so the next concept will be our 3-pin plug. So for the 3-pin plug, what is inside a 3-pin plug? Basically, there is 4 things. Okay, so the first will be our neutral wire. So the neutral wire is coded in blue color because we need to code the thing so that we know which wire is which. So the neutral wire, that is the first. The second will be your earth wire. Okay, and the third will be your live wire. Okay, and of course, don't forget there's always a fuse located next to the live wire right here. Okay, so these 4 things are the basic things that will be found inside your 3-pin plug or 3-pin plug. Okay, so for the what is the neutral wire? So you can see that for the neutral wire is known as the neutral because it's 0 volts. What is the live wire? The live wire is 240 volts in the context of Singapore. So for the live wire is to supply the current to the electrical appliance. So for example, I have a heating element or kettle right here. So I plug this switch into a socket, power socket. So this live wire will draw the current into the electrical heating element. So of course I close the switch, and after that I go through the heating element, and this heating element will heat up. So after that, the current will flow back via the neutral wire. Because remember, for current to flow, you must ensure that the current flows out of the house and go back home. Okay, so that is the main the purpose of your live and neutral wire. What about the earth wire? So the earth wire is connected. You can see that the earth wire right here is connected to the metal casing of the element or of the metal casing. This is actually something to protect us from getting electrocuted, which I will mention about this later. Okay, so that is the earth wire, which is 0 volts and is connected to the metal casing for safety purpose. Okay, the next thing is also very important, which is the fuse. Okay, the fuse is something like a glass porcelain tube. Inside this glass tube, right, there's a very thin wire. So when the current is flowing, when there's excess current flowing, and when the excess current flows, right, exceeds the value of the fuse, it will cause the fuse metal to melt and break. Okay, so some of the value of the fuse can be seen here. It's normally whole number lah. So common fuse rating is 1 ampere, 2 ampere, 5 ampere, 10 ampere, and 13 ampere. So every electrical appliance has its own fuse depending on what current is operating at. So for the example of the previous video, so for these 2 kettles, right, so for low power kettle, we have an operating current of 0.25 ampere. So of course, when we install the fuse, I must make sure that the fuse is slightly higher. It's not equal, must be slightly higher. So the next slightly higher fuse will be about 1 ampere. What about the second, which is the high power electrical kettle? So it's about 12.5 ampere. So the fuse that I want to install is roughly it's about 13 ampere lah. Okay, so yeah, so the fuse is it's a safety device that will be located on the live wire. Okay, so just take note that for the fuse rating, right, it must be slightly higher. Okay, so if I give you 4 cases, if the fuse rating is much higher than the operating current, what will happen? So the very first thing is the fuse does not melt and break. So for the example of maybe for the low power kettle, 0.25 ampere, if I install maybe a 10 ampere fuse, so it will allow a current of much greater than the current drawn, right, to pass it. And this large current will in turn overheat the electrical appliance and damage before the fuse blows. Okay, so that is the reason why I do not put a very high fuse into into the operating current thing, right? So okay, case 2, if your fuse rating is just a bit slightly higher than operating current, so the electrical appliance will still operate normally and safely, of course. So if excess current drawn, right, the fuse will melt and break. So this will actually prevent overheating. So yeah, so this to prevent overheating. Okay, what about case number 3? So if you have a fuse rating, so let's just say the kettle of 1 ampere, so it's drawing a current of 1 ampere. If you put a fuse rating of 1 ampere, right, and you switch on the electrical appliances, the electrical appliance will not work at all because the thing will just melt and break. So no current is going to flow through. So of course, case number 4 is the fuse rating is lower than the operating current. The thing will not work at all. Okay, so it's very important that the fuse must be slightly higher than the operating current. So these are the 4 important things. Okay, of course, for the besides knowing the live earth neutral, right, we also need to know the orientation of the neutral earth and live wire. Okay, so just remember in a 3-pin plug socket, right, always remember this: north, east line. Okay, so northeast line, right? So that's the orientation. So the northeast line is like N for neutral wire, E for earth wire, L for live wire. And the live wire must be always located next to the fuse. Okay, there's one last thing that I want to take note is your cable grip. So the cable grip right here. So the cable grip actually is very important because there's a year where this cable grip question come up in 2009. I believe it's 2009 O-level question. So this cable grip, you must ensure that it's gripping on the outer insulation. Okay, so what if it doesn't grip on the outer insulation? This will be the so-called picture that I'll show you right now. Okay, so this is a picture. So you can see that the cable grip is not gripping on the outer insulation. So what happens is that if I pull this thing right out, if I pull hard enough, these 3 wires right here will just come out of the of the socket. So this is something that is very dangerous, right? So yeah, so that is the purpose of your cable grip. Okay, so yeah, so the next thing will be the potential. Okay, so let me go back. Okay, so for north, east, right, for the neutral and east, for the earth wire, right, the potential will be 0 volts, but okay, let me write down first, 0 volts. But for live wire, it's about 240 volts. Okay, so that's why live wire is rather dangerous because of the high potential. Okay, so of course the next thing we must memorize is the color. Brown, yellow, green, and blue. So neutral, you just think of the sky, which is blue in color. Earth, you think of the grass, or green and a bit of yellow. Live is a bit of danger, right? So it's a bit reddish or reddish brown like that, right? So the next thing is, okay, if the electrical appliance is operating normally, there is current flow in both your live wire and your neutral wire. Because remember, the live wire is supplying the current, right? It's drawing the current out from the so-called power socket to the electrical heating element. So if the current must go back home via the neutral wire. So that's why both your live and neutral wire have current. Okay, just that for the difference between live and neutral is the live is 240 volts, the neutral is 0 volts. And there's actually a very simple reason why the live and neutral wire is 240 and 0 volts respectively. Remember in the chapter of COE or DC circuit, in order for current to flow, we must have a potential difference. So for the live wire, we have a potential of 240. Neutral wire is 0 volts. So the potential difference is actually 240 volts. Hence the current is able to flow. Let's just say I have something like this. If my live wire is 240, right, volts, and I have a heating element right here, and I have a neutral wire of the same potential of 240 volts. Do you think the current can flow? The current cannot flow because there's no potential difference. It's something like maybe, let's just say you have a flat land or horizontal ground. You put a ball on this horizontal ground, the thing will not flow. I mean the ball will not roll at all because there's no incline, right? Yeah, so the same thing for your current. You need a potential difference to flow. So that's why for live and neutral wire, there must be 240 and 0 volts respectively. Alright, yeah. So that is the main thing about your live and neutral wire. Okay, so of course during normal operation, the earth wire, there shouldn't be any current. So there shouldn't be any current right here. If there's electrical fault, means that maybe the live wire right here, there's a free live wire touches the metal casing of the heating element. Yes, then there will be current flowing through the earth wire. So that is the main thing about your 3-pin plug.